Stepping back once more to consider the absolute broadest possible framing of this entire story, it is worth explicitly acknowledging that this particular secure boot certificate transition, on its own, considered purely in isolation, genuinely does represent a fairly routine, competently managed piece of essential infrastructure maintenance, rather than any kind of a genuine crisis or catastrophe. Security. Researchers and technology journalists covering this specific transition have been remarkably consistent and unified in emphasizing that point clearly and repeatedly throughout their coverage. The actual technical execution of this transition, providing months of genuine advance notice, coordinating directly and cooperatively with every single major Linux distribution well, ahead of time, and ultimately delivering a smooth, low-disruption transition for the overwhelming majority of the world's actual Linux user base, genuinely deserves credit as a reasonably well-handled piece of complex, high-stakes infrastructure engineering. What makes this specific story genuinely worth a deeper, more thoughtful look, though, is not really about criticizing this one particular transition's actual technical execution at all. It is specifically about what this entire episode reveals, almost as an illuminating side effect, about the surprisingly deep structural dependency that the supposedly independent, famously decentralized world of Linux still quietly, continuously maintains toward a single company that Linux itself, as an entire operating system and broader philosophical movement, was originally created specifically to offer users a genuinely independent, free alternative away from in the first place. That underlying tension, an operating system built explicitly around openness and independence, nonetheless remaining quietly, structurally dependent on its historically biggest commercial competitor for something as fundamentally basic as whether your computer even successfully starts up in the first place, represents a genuinely worthwhile, ongoing conversation for the broader Linux and open source community to keep having, regardless of how smoothly or competently this particular specific transition itself ultimately turned out to be handled. So what does all of this actually mean, practically speaking, for the average Linux user reading or watching this story right now? If you are running a modern, actively maintained Linux distribution on reasonably current hardware, the honest, straightforward, practical answer is genuinely simple. Make sure your system is reasonably up to date by running your normal package. Manage your update commands, and you have almost certainly already handled this entire transition without ever needing to think about it consciously at all. If you happen to be running considerably older hardware or a Linux distribution that receives less frequent or less reliable maintenance updates, it is genuinely worth taking a few minutes to specifically check whether your system has already received an updated dual-signed shim package. And if you run Linux on your computer, there's a very real chance that every single time you turn it on, a certificate owned entirely by Microsoft is quietly deciding whether your own operating system is even allowed to start up in the first place. That might sound like an exaggeration, but it is not. On June 27th, 2026, one of the specific certificates responsible for this exact process officially expired. And while the sky did not fall and computers did not suddenly stop booting, the entire episode exposed something genuinely open source world of Linux still quietly depends on a piece of infrastructure, controlled entirely by its biggest historical rival. To understand why this matters, you first need to understand a security feature called a secure boot. And the honest truth is that most people, even many Linux users themselves, do not fully understand how it actually works under the hood. Secure boot exists to solve a genuinely serious security problem, protecting your computer against something called a bootkit, a particularly nasty type of malware that infects your machine at the very earliest possible stage before your actual operating system, whether that is Windows or Linux, ever even finishes loading. Because a bootkit runs before your operating system's own security protections have a chance to activate, it can be extraordinarily difficult to detect and remove using conventional antivirus tools, since those tools themselves only start running after the operating system has already loaded. Secure boot works by creating what is essentially a chain of digital trust, checking a cryptographic signature at every single stage through to your actual operating system kernel. If any single link in that chain has been tampered with, or is not properly signed by a trusted authority, Secure Boot is specifically designed to refuse to let that unauthorized code run at all. This is genuinely valuable protection, and it is honestly one of the more successful, widely adopted security innovations to come out of the PC industry in the last 15 years or so. Here is where things get specifically complicated for Linux users, though. Almost every single popular Linux distribution, including Ubuntu, Fedora, Red Hat Enterprise Linux, and many others, relies on a small piece of software called shim to actually make Secure Boot work correctly on Linux systems. And that shim, the literal first stage bootloader that most Linux distributions depend on, has been signed for well over a decade, using a certificate owned and controlled entirely by Microsoft, specifically something called the Microsoft Corporation UEFI CA 2011 certificate. Think about that for a moment. The overwhelming majority of the world's Linux computers, machines proudly running an operating system built specifically as an open, independent alternative to Windows, have spent the last decade booting up successfully only because Microsoft was willing to digitally sign the exact piece of code that makes that boot process possible in the first place. Why would Linux distributions agree to depend on a certificate controlled by their biggest competitor in the first place? The answer comes down to a practical reality of how modern PC hardware is actually manufactured. The vast majority of computers sold today, especially by mainstream manufacturers like Dell, HP, and Lenovo, ship from the factory with Microsoft's own secure boot certificates already pre-installed directly into the computer's firmware, specifically because those same computers are primarily designed and certified to run Windows. For a Linux distribution to boot successfully on that exact same hardware, without requiring the average user to manually dig into their computer's firmware settings and add a separate certificate themselves, that Linux distribution needs its own bootloader to be signed using a certificate that is already trusted by the firmware, straight out of the box. And for most PCs sold over the last decade, that has specifically meant getting Microsoft's own signature. So, back on June 27th, 2026, Microsoft's original 2011 signing certificate officially expired, exactly as scheduled, as part of what security researchers have specifically described as a deliberate, planned key rotation rather than any kind of surprise or crisis. Microsoft has been working for months to transition everyone over to a newer certificate called the Microsoft UEFI CA 2023. And if you're running a modern, actively maintained Linux distribution on relatively recent hardware, the honest, straightforward truth is that this entire transition likely affected you either not at all, or only in the mildest, most easily manageable way imaginable. If you're finding this breakdown genuinely useful, go ahead and hit that like button and subscribe to the channel, because we regularly break down major technology stories exactly like this one. Here's exactly what actually changes, and just as importantly, what does not change, because there has been a genuinely significant amount of confusing, occasionally alarmist information circulating online about this specific certificate expiration. Your computer does not suddenly stop booting the moment that old certificate expires. Systems that were already successfully booting using shim, signed by the 2011 certificate, continue booting exactly as they always have, since the expiration specifically affects Microsoft's ability to sign brand new shim binaries going forward, not the ability of already trusted binaries to keep working. Major Linux distributions, including Red Hat Enterprise Linux, Alma Linux, Rocky Linux, Fedora, Ubuntu, and Debian, had all already prepared for this exact transition well in advance, releasing what is called a dual-signed shim, meaning a single bootloader binary carrying valid signatures from both the old 2011 certificate and the newer 2023 certificate simultaneously. That dual signing approach means the exact same shim binary will successfully boot on any machine, regardless of whether that machine's firmware currently trusts the older certificate, the newer certificate, or both at once. For the average person running a modern, actively maintained Linux distribution, the entire practical fix here comes down to something genuinely simple: running your normal, everyday package update commands. On a Red Hat-based system, that typically just means running your standard update command to pull in the latest shim package. On Fedora, running a specific command to update the shim package directly does the job. On Ubuntu or Debian-based systems, your regular system update process should handle it automatically as well. For most Linux users, the entire fix genuinely requires nothing more dramatic or complicated than making sure your system's packages are reasonably up to date, exactly the kind of routine maintenance most Linux users already perform on a fairly regular basis anyway. But here is exactly where the story stops being a minor, easily resolved technical footnote and starts revealing something functions. Security researchers and Linux commentators covering this specific transition have been quick to point out that what genuinely remains unresolved is what they specifically describe as the long tail, older laptops from smaller, less prominent manufacturers, embedded devices, and specialized industrial equipment that shipped years ago and will likely never receive another firmware update again for the rest of their operational lifespan, and machines belonging to users who, for whatever reason, simply are not running the kind of regularly updated, actively maintained Linux distribution that most of the major players have specifically prepared for this exact transition. For those specific users, running genuinely older, unsupported hardware, the situation becomes meaningfully murkier and more uncertain. if a particular laptop's manufacturer never releases a firmware update specifically adding support for Microsoft's newer 2023 certificate, and that same machine's currently installed shim was only ever signed using the older, now expiring 2011 certificate, that happens to require a freshly signed shim binary, precisely because Microsoft can no longer sign any brand new shim using that older expired certificate going forward. Security researchers covering this story have specifically acknowledged that nobody currently has a fully clean, comprehensive answer for exactly how significant this problem will eventually become for that specific long tail of aging, unsupported hardware, and that the true scope of the issue likely will not become fully clear until real users out in the field genuinely start running into it directly over the coming months and years. If you are enjoying this deep dive into how modern computing infrastructure actually works behind the scenes, now is a great time to hit that subscribe button because we cover breaking technology stories exactly like this one on a regular basis. Now, it is worth stepping back and asking the genuinely bigger, more uncomfortable question buried underneath this entire specific certificate transition story. Why does Linux, an operating system built from the ground up, specifically around the principles of openness and independence from any single controlling company, remain so quietly, structurally dependent on Microsoft in the first place for something as fundamentally basic and important as whether your computer is even allowed to start up at all? This is far from an isolated, one-off dependency either, and this particular secure boot certificate situation is actually just one small piece of a considerably larger, more troubling pattern that has become increasingly visible throughout 2026. Just a couple of months earlier, in April 2026, an entirely separate but conceptually related controversy erupted when Microsoft abruptly suspended the developer accounts belonging to several major open source security projects, including VeraCrypt, a widely used open source disk encryption tool, and WireGuard, a modern, extremely popular VPN protocol that underpins numerous commercial VPN services people rely on every single day. Both of these accounts were specifically used to digitally sign Windows drivers and bootloader components, a completely different but structurally very similar kind of Microsoft-controlled trust dependency. According to the developers directly affected, Microsoft suspended these accounts with absolutely no advance warning, no clear explanation, and seemingly no straightforward path to actually appeal the decision or reach an actual human being at Microsoft capable of helping resolve the situation. VeraCrypt's lead developer, Munir Idrasi, described the situation in genuinely stark terms, explaining that Microsoft had terminated an account he had personally used for over 8 years to sign Windows drivers and the VeraCrypt bootloader itself, receiving no prior warning whatsoever, and being told explicitly that no appeal was even possible. WireGuard's own creator, Jason Donenfeld, reported an almost identical experience, discovering his own account suddenly marked as access restricted with absolutely no accompanying explanation, right in the middle of ongoing work specifically aimed at getting a new WireGuard driver properly certified for Windows. And this particular disruption carried real, tangible stakes attached to it as well, since VeraCrypt users who had encrypted their entire Windows system drive could potentially face serious boot failures down the road if the software's bootloader signature could not be properly renewed in time. And WireGuard sits underneath numerous popular commercial VPN services that tens of millions of people worldwide actively rely on every single day. It genuinely took a very specific combination of significant public outcry, extensive media coverage, and eventually direct personal intervention from Microsoft Vice President Scott Hanselman before these specific accounts finally got restored and functioning normally again. While this particular incident directly affected security tools running specifically on Windows rather than Linux itself, it points toward exactly the same underlying structural issue quietly running throughout this entire episode: the fact that a huge amount of genuinely critical infrastructure, spanning both the Windows and Linux ecosystems, ultimately depends on Microsoft's continued goodwill, administrative competence, and willingness to keep specific developer accounts and signing certificates active and functioning correctly, often without any meaningful backup plan or independent alternative readily available if something suddenly goes wrong. This exact same underlying pattern shows up again in a conceptually related but technically distinct way, specifically within the broader open source software supply chain more generally. Security analysts covering this broader trend have specifically pointed out that Linux, despite being fundamentally decentralized by design in terms of how its actual source code gets written and maintained by contributors scattered all across the world, has nonetheless become increasingly quietly centralized when it comes to how that same code actually gets delivered, packaged, signed, and distributed to end users. A relatively small handful of major hosting providers and certificate authorities, including Microsoft itself, function as genuine single points of failure sitting directly underneath an ecosystem that markets itself heavily around the specific idea of decentralized, independent, community-controlled software development. When a maintainer's account gets suspended, or a critical signing certificate suddenly becomes unavailable, the actual open source code itself does not disappear or stop existing anywhere. But the practical, real-world ability to deliver trusted, properly signed updates of that exact same code out to millions of actual end users can grind to a complete halt almost instantly, precisely because that specific delivery mechanism depends entirely on a small number of centralized services that the broader open source community itself does not directly own, control, or have any meaningful backup alternative readily available for, should something suddenly go wrong. It is also worth understanding exactly why this specific dependency on Microsoft's signing infrastructure came about in the first place, rather than simply assuming it reflects some kind of historical accident or oversight. Secure Boot itself was originally introduced, specifically as part of Windows 8 hardware certification requirements roughly 15 years ago, and at the time, the Linux community actually raised genuinely serious, well-founded concerns that this new security feature could potentially be misused specifically to lock competing operating systems out of PC hardware entirely, effectively creating exactly the kind of restrictive, Windows-only computing environment that critics feared at the time. Microsoft ultimately responded to that specific pressure by agreeing to sign Linux's OwnShim bootloader, allowing Linux distributions to boot successfully on the exact same secure boot, enabled hardware that ordinary consumers were increasingly buying, specifically pre-configured to run Windows straight out of the box. That arrangement, whatever its original motivations may genuinely have been, has generally worked reasonably well, and without major incident for well over a decade now. But this most recent certificate expiration episode, arriving in the same general period, as that entirely separate developer account lockout controversy affecting VeraCrypt and WireGuard has understandably reignited a genuinely important, long-simmering conversation within the broader Linux and open source community about whether this specific kind of structural dependency on a single company, however cooperative and well-intentioned that company's stated intentions may genuinely be, represents a wise, sustainable long-term arrangement for an ecosystem that has always prided itself specifically on independence, decentralization, and freedom from any single controlling corporate entity. Some security researchers and Linux advocates covering this exact debate have specifically argued that this entire episode should serve as a genuine wake-up call, pushing the broader Linux community toward developing more robust, more thoroughly independent alternatives for critical infrastructure functions like secure boot signing, ones that do not require Linux distributions to remain permanently structurally dependent on their historically biggest commercial rivals' continued goodwill and administrative reliability. Others have taken a more measured, pragmatic view, pointing out that Microsoft has actually handled this specific certificate transition itself quite responsibly and professionally, providing months of genuine advance notice, working directly and cooperatively with major Linux distribution maintainers well ahead of the actual expiration deadline, and ultimately ensuring that the overwhelming majority of Linux users experience this significant infrastructure transition with essentially zero real-world disruption to their daily computing experience. Both of these specific perspectives genuinely contain real merit, and they are not actually mutually exclusive or contradictory in any meaningful sense. Microsoft can absolutely have handled this specific technical transition itself responsibly and professionally, while the underlying structural dependency it exposes still remains a genuinely legitimate, worthwhile subject for serious concern and discussion. A well-managed transition process handling a single specific incident does not necessarily eliminate the broader, more fundamental risk of remaining permanently dependent on a single external company for something as fundamentally critical as whether your own computer's operating system is even allowed to boot up successfully in the first place, especially given that the exact same underlying company demonstrably suspended several completely unrelated developer accounts with zero warning whatsoever just a couple of months earlier in that entirely separate incident. It is also worth understanding a slightly more technical but genuinely important additional wrinkle buried inside this specific certificate transition, one that offers a useful window into how carefully this whole process was actually engineered behind the scenes. Alongside signing Linux's OwnShim bootloader, Microsoft's original 2011 certificate has also historically been used for an entirely separate purpose, signing something called third-party option ROMs, small pieces of firmware code that live directly on expansion hardware like graphics cards and network interface cards, helping that hardware properly initialize during the earliest stages of your computer's startup process. As part of this broader certificate transition, Microsoft has specifically split that particular function off into its own separate dedicated 2023 certificate, rather than continuing to bundle it together with the certificate specifically responsible for signing operating system bootloaders like shim. This might sound like an obscure, purely technical detail, but security researchers have specifically pointed out that it actually represents a genuinely meaningful security improvement in its own right. Under the older bundled arrangement, any computing environment that trusted Microsoft's certificate specifically to allow Linux's shim bootloader to run was, by definition, simultaneously trusting that exact same certificate to also validate arbitrary hardware option ROMs from any number of third-party manufacturers, a considerably broader, less precisely scoped form of trust than most security-conscious organizations would probably prefer to grant if given the choice. By deliberately splitting these two distinct functions into separate certificates, Microsoft has effectively allowed organizations and individual users alike to trust Linux's own boot process specifically, without being forced to simultaneously extend that exact same blanket trust toward an entirely separate category of third-party hardware firmware that has genuinely little direct connection to the core question of whether your actual operating system itself can be trusted to boot up safely and securely. That said, security researchers have also specifically noted that this particular architectural change is new enough that certain edge cases and unusual configurations are still actively surfacing as different organizations and individual users work through the practical details of this transition in real time. This is a genuinely common, expected pattern whenever any large, complex piece of foundational computing infrastructure gets meaningfully restructured, even when that restructuring is carefully planned, well tested in advance, and ultimately represents a clear net improvement in how the underlying system actually functions going forward. It is also worth taking a closer look at exactly how individual Linux users can personally verify whether their own specific system has already been properly prepared for this entire transition, since this kind of direct, hands-on verification offers genuine, practical peace of mind, rather than simply having to take it on faith that everything has already been quietly handled correctly in the background. Most Linux distributions provide a specific command line tool that allows any user to directly inspect exactly which certificates their own computer's firmware currently trusts. Running that specific command and checking whether the output includes both the older Microsoft Corporation UEFI CA 2011 entry and the newer Microsoft UEFI CA 2023 entry tells you directly, with total certainty, whether your own specific firmware has already been properly updated to support this transition, assuming your system's shim bootloader itself has also already been updated to carry both corresponding signatures as well. If a user runs that specific verification command and discovers that only the older 2011 certificate entry appears in their own firmware's trusted list, the most common, straightforward fix in the vast majority of cases simply involves running a standard firmware update utility that many major Linux distributions include by default, which pulls relevant firmware updates directly from a centralized Linux vendor firmware service whenever a user's specific hardware manufacturer has already published an appropriate compatible update. Major manufacturers including Dell, HP, and Lenovo had already published exactly these kinds of necessary updates well ahead of the actual June 27th deadline for the vast majority of their more recent computer models. If that specific firmware update utility comes back reporting that no relevant update is currently available for a user's specific hardware model, the only genuinely reliable remaining path forward typically involves checking that exact same hardware manufacturer's own official support website directly, since not every single firmware update from every single manufacturer necessarily flows automatically through that centralized Linux vendor firmware service in every single case. It is also worth spending a moment considering exactly which specific categories of Linux users actually face the greatest genuine risk from this particular certificate transition, since understanding that specific risk profile helps clarify exactly why this story deserves genuine, serious attention, despite affecting only a relatively small minority of the overall Linux user population directly. Users running long-term support versions of major, well-resourced distributions like Ubuntu, Fedora, or Red Hat Enterprise Linux on relatively recent hardware from major manufacturers face essentially minimal practical risk, since both their specific distribution's own software updates and their hardware manufacturer's own firmware updates have already been thoroughly prepared and tested well in advance of the actual deadline. The users facing meaningfully greater practical risk tend to fall into a few specific, identifiable categories. Users running genuinely older laptops or desktop computers, particularly ones manufactured by smaller, less prominent companies that may not maintain the same kind of long-term firmware support commitment that larger manufacturers typically provide, represent one clearly identifiable risk category. users running specialized embedded computing devices, industrial control systems, or purpose-built hardware that shipped with Linux pre-installed years ago and was never really designed to receive ongoing firmware updates throughout its entire operational lifespan represent another genuinely significant risk category. And users running smaller, less actively maintained Linux distributions that may not have dedicated the same kind of engineering resources toward preparing dual-signed shim packages well ahead of the actual deadline represent a third, somewhat less predictable risk category worth keeping in mind as well. For all three of these specific risk categories, the practical consequences of this transition likely will not manifest immediately or dramatically. Instead, security researchers have specifically emphasized that the genuine risk here primarily involves what happens the next time that one of these specific systems needs a freshly signed shim binary. Perhaps because a serious new security vulnerability gets discovered requiring an urgent patch, or because a user eventually needs to reinstall or meaningfully reconfigure their existing Linux installation for some entirely unrelated reason. At that exact future moment, if Microsoft can no longer sign a brand new shim binary using the now expired 2011 certificate, and a particular user's specific hardware firmware has never been updated to trust the newer 2023 certificate instead, that specific user could genuinely find themselves stuck, unable to successfully apply an urgently needed security update through the normal expected process. This is precisely why security researchers covering this story have specifically recommended that users running genuinely older, potentially unsupported hardware take a couple of straightforward, proactive precautionary steps sooner rather than later, rather than simply waiting passively to see whether a genuine problem eventually materializes down the road. Specifically, updating your system's existing shim package now, while it can still technically be signed using the still valid 2011 key during this particular transition window, and then carefully, deliberately evaluating any future shim updates before blindly applying them, without at least some basic verification, represents a genuinely sensible, low-effort precaution for exactly this specific category of potentially vulnerable, longer-term unsupported hardware. Stepping back once more to consider the absolute broadest possible framing of this entire story, it is worth explicitly acknowledging that this particular secure boot certificate transition, on its own, considered purely in isolation, genuinely does represent a fairly routine, competently managed piece of essential infrastructure maintenance, rather than any kind of a genuine crisis or catastrophe. Security. Researchers and technology journalists covering this specific transition have been remarkably consistent and unified in emphasizing that point clearly and repeatedly throughout their coverage. The actual technical execution of this transition, providing months of genuine advance notice, coordinating directly and cooperatively with every single major Linux distribution well, ahead of time, and ultimately delivering a smooth, low-disruption transition for the overwhelming majority of the world's actual Linux user base, genuinely deserves credit as a reasonably well-handled piece of complex, high-stakes infrastructure engineering. What makes this specific story genuinely worth a deeper, more thoughtful look, though, is not really about criticizing this one particular transition's actual technical execution at all. It is specifically about what this entire episode reveals, almost as an illuminating side effect, about the surprisingly deep structural dependency that the supposedly independent, famously decentralized world of Linux still quietly, continuously maintains toward a single company that Linux itself, as an entire operating system and broader philosophical movement, was originally created specifically to offer users a genuinely independent, free alternative away from in the first place. That underlying tension, an operating system built explicitly around openness and independence, nonetheless remaining quietly, structurally dependent on its historically biggest commercial competitor for something as fundamentally basic as whether your computer even successfully starts up in the first place, represents a genuinely worthwhile, ongoing conversation for the broader Linux and open source community to keep having, regardless of how smoothly or competently this particular specific transition itself ultimately turned out to be handled. So what does all of this actually mean, practically speaking, for the average Linux user reading or watching this story right now? If you are running a modern, actively maintained Linux distribution on reasonably current hardware, the honest, straightforward, practical answer is genuinely simple. Make sure your system is reasonably up to date by running your normal package. Manage your update commands, and you have almost certainly already handled this entire transition without ever needing to think about it consciously at all. If you happen to be running considerably older hardware or a Linux distribution that receives less frequent or less reliable maintenance updates, it is genuinely worth taking a few minutes to specifically check whether your system has already received an updated dual-signed shim package, and if it has not, looking directly into your specific hardware manufacturer's own support resources for any available firmware updates that might still be necessary. But beyond the immediate practical technical fix itself, this entire episode is genuinely worth remembering as a small but meaningful data point in a much larger, ongoing conversation about digital independence, structural dependency, and exactly how much quiet, often invisible trust we all place, frequently without ever really thinking about it consciously, in a relatively small handful of large, powerful technology companies, even when we ourselves are actively, deliberately choosing to use software and operating systems specifically designed and marketed around the core principles of openness, independence, and freedom from any single corporate gatekeeper's ultimate control. There is also a useful, slightly broader lesson embedded in this story, specifically for anyone who has ever assumed that choosing open source software automatically means fully escaping the influence of large, dominant technology companies altogether. In practice, the modern computing landscape is woven together by an enormous number of interlocking dependencies, certificates, hosting providers, hardware manufacturers, and signing authorities, and very few pieces of software, no matter how philosophically committed to independence and openness, manage to exist in complete isolation from that broader web of infrastructure. Recognizing exactly where those specific dependencies actually exist, rather than assuming they simply do not exist at all purely because a piece of software carries an open source label, is a genuinely valuable habit for any technically curious person to develop, regardless of which particular operating system they personally happen to prefer using day to day. None of this is meant to suggest that Linux users should suddenly feel anxious or distrustful about their own choice of operating system. Linux remains, by virtually every meaningful measure, one of the most secure, most flexible, and most genuinely community-driven pieces of software in existence today, and this specific certificate transition ultimately resolved itself with minimal real-world disruption for the overwhelming majority of actual users. But understanding stories, exactly like this one, quietly unglamorous, mostly resolved without incident, yet genuinely revealing about deeper structural dependencies most users never consciously think about, is precisely the kind of informed, clear-eyed perspective that helps the broader Linux and open source community continue having honest, productive conversations about where genuine independence currently exists and where quieter, less visible dependencies still remain worth addressing over the years directly ahead. If nothing else, this entire episode is a genuinely good reminder to keep your own systems reasonably updated, check your firmware settings every once in a while, and remember that even the most independent-seeming piece of technology usually has at least one quiet dependency running underneath it that most of us never think about until the exact moment it briefly becomes news. Before you go, make sure you are subscribed to the channel with notifications turned on, because major technology stories exactly like this one keep unfolding at a genuinely fast pace throughout 2026, and we will be right here breaking down the next one the moment it happens.